Okay, hello everyone, and welcome to today's webinar session. Thank you for joining the webinar. My name is Abhishek, and I am the IoT market analyst and core member of the business development team at Factana. So, to begin, let's introduce who we are. So, we are a cognitive IoT company specialized in industrial automation. We provide industrial IoT solutions to small and medium businesses. So our product is Fogwing, and Fogwing is an industrial IoT platform available for small and medium businesses. We are also providing an environment monitoring solution, and the name of this application is Fogwing Eco. And it's a plug and play model, and it is used mostly for monitoring the climate condition of the warehouse, greenhouse, establishment, and laboratories, and other climate critical industries. So moving on, this webinar will be presented by Mr. Hari, who is our founder and chief architect of Factana. And for today's session, we are focusing on Industry 4.0, what is the right wireless IoT network for smart manufacturing. Hari, over to you.
Thank you, Abhishek. Hello, everyone. Good evening, good afternoon, and good morning, wherever you are watching from. IoT is one of the top 10 technology being considered for strategically on the enterprises, especially on the industries such as manufacturing, logistic, agriculture, and other sectors started considering IoT as one of the key enabler for transforming the business to the next level by understanding various aspects of the business and things like that. However, IoT is heavily relying on technology, right? On the advancement in the telecom technology. So there are various telecommunication wireless networks being there across the globe. Different countries, different standards, different level of telecommunication providers are there. So the question is, what is the right technology for smart manufacturing, especially manufacturing companies that spread across multiple countries, manufacturing that interact with the other country suppliers and providers, logistic companies, and things like that, right? So that's a very important point to understand. What would be the right technology that we should choose with, considering all these factors across different regions. So to get into that, we need to understand a little more on the foundation level. There are many different network protocols we have seen in the past, but it's very specific to the IoT space because it's more like a device communication, machine communication. We need to understand what is the most robust way of connecting, right? So just to go, let's understand a little bit on the foundation layers for the IoT communication. Of course, the fundamental of standards, the industry, IEEE standards is the network principles and things like that. IPv4 and V6 are giving more on the internet-ready connected, devices or systems that can communicate to any system by giving a unique identification on that. And the next level of one is more like a transportation layer, right? So in the transportation layer, TCP/IP or UDP or HTTP over wire, we communicate between these two systems. So the systems can identify it and system can communicate between them in the transportation layer principles and protocols. On the application side, especially IoT application side, the most common and most industry standard approach of connecting between the systems or devices the most common one is MQTT standard and CoAP and APIs. So APIs are getting better now. Still, as per the standard aspect of that, MQTT is most commonly applied application layer communication mode between the devices. So understanding that, we have a wide variety of layers are there and security standards are there. The most common one or the most commonly applied are based on the type of device and other flexibilities. On the networking side, right, as we talked about it, the wireless network being there for quite a long time, but these technologies are vary from time to time. Advancements happened in the technology area, wireless technology network area. So we let's take a look at and what are the different options available right now, and how do we group it together, right? From the RFID, the traditional RFID based scanning and communication, to the most common one that we use in day-to-day life, or BLE, or Bluetooth BLE, near field communication. These are most common mobile specific communication, or mobility specific communication, wireless communication, or wireless network is available. But in terms of the IoT space, we need to look at a little more larger aspect of that. As the number of systems are connected, the more number of systems are getting connected, the more complex challenges needs to be addressed, and those challenges are addressed in a specific standards within the wireless network space, starting from Wi-Fi and Lo-Fi, simple connections, wireless connections that are available commonly across all over, and the devices are much cheaper to apply and get things connected to another environment, or device to device communication, things like that. But more widely used, the wide area network aspect of that, we need to look at what is it long range, wide applicable things, as the internet of things might be anywhere, and it's the machineries could be moving parts, and that requires a significant broader coverage area as well. And in that case, the most common one that we know today is the cellular network. As we use the mobile phone, we roam around across different places. The coverage is pretty much everywhere, right? And the cellular is the most common one. But cellular also has has some impacts in terms of the usage. The other standard technologies, low power technologies, are very, very important in the IoT, especially when we are deploying devices on the remote places. The power consumption is a significant factor that we need to consider. So low power wide area network is very, very important consideration before we identify what is the right wireless network for our use case, or for your use cases and things like that. So there are different specifications available in this space on the low power consumption, and we are going to take a look at that deeper into that. We are going to look at more longer running devices. We need to look at more broader long range devices that might be deployed under remote cases. 90% of the IoT deployments are long range requirements, as we don't need something next to us, right? And just we can see that. We need something that is far away from us. We need to understand some component, some information that available far away from us, right? So that's a very common, most useful, considerable deployment on the IoT space. So in that case, there are the long range, right? The range might vary from different level, from 100 meter to 10K meters, or 10 kilometers ranges. So it could vary from place to place, depending upon the use cases, depending upon the level of use cases and application level and things like that. Now, in that spectrum, there are speed and bandwidth are critical players, and also the life of the battery, right? Because the remote places, the more remote it is, the better battery life is required to consistently create a data or generated data and send it to the platform for analysis and mining that data. So in that case, we not only required a long range, we also need a better data rate in terms of the bandwidth, and the level of data that can be published by the device, and also the level of battery consumption. So we need to look at all those parameters to understand what would be the right wireless network for our IoT use cases. Now, if you look at that, in that aspect of that, let's talk about the cellular network, the most common one, right? The cellular network, the 2G, 3G, 4G, or even 5G, our most common one. We are roaming around in the mobile app. We can use a similar. Mobile is considered as a device. In fact, mobile is one of the IoT device, right? So mobile is considered as a device that can roam around all of the places wherever the cellular network available, and we can leverage those cellular network to do that. But the data rate and the and bandwidth and the speed availability might vary depending upon the type of level of cellular network is available. If it's a 2G, it cannot be, we cannot stream the live data properly. If it is a 5G, we can stream a live video data through the devices, right? So it depends upon the level of spectrum available on that location, especially the remote location. The next level, we need to consider, but the cellular network required a lot more power consumption. As it takes power to communicate to long range, as well as it takes power to, as more frequently we generate the data, that's going to consume more power in terms of transmitting over the network or over the wireless. Second level, looking at that, the low power consumption. Low power consumption or low power spectrums are required different level of licensing need. The cellular networks are more licensed network. In the low power network, there are two level of frequencies are available. In terms of the license, the cellular network providers also provide a low consuming network in the lower band on that, and they are providing some of them like a LTE-M. LTE-M is more like a mobile based frequency, and then NB-IoT is a most common one provided by the cellular provider itself on the low power consumption, especially for the IoT cases, narrow band IoT implementation. This is specially created, band one for the IoT specific use cases by the cellular network providers to handle the volume of and need of IoT implementation. On the lower band, of course, there are two major players that we are radio frequency, lower unlicensed radio frequency. We are looking at the two major player, the LoRa specification as well as Sigfox specification. There are two major contender on that space who provides the network specification to support low power consumption as well as the long range. So that's the beauty of that, right? So we get a longer range and lower power consumption. But there are some impacts as well in terms of the number of data that we can produce and number of, the level of size of the data and volume of the data and how much we can transmit and things like that. There are certain limitations on that. That's what we are going to look at as a next step into this. By considering the remote IoT cases, right? IoTs, we typically it's going to be a remote place, and the availability of the power is a question. So it's always preferable to go with the low power consuming devices while communicating from the remote places. So if you look at that, the most key common contender in this space are LoRa, Sigfox are the unlicensed frequency specification, and NB-IoT, LTE-M are the most licensed specification. And there are advantage of both sides. There are disadvantage on both sides, and let's take a look at that in each one. Now, starting from the cellular network, right, and which is most commonly we know that as we use the mobile solutions. The availability of the network across global varies again, right, because of the different network providers across different countries. In general, the global GSM association published the data on how much coverage is available across the global. If you look at the cellular network, especially LTE-M, NB-IoT based cellular network, low power cellular network, available across North America, South America, and European region. However, you can see the gap on the African region and South Asia and Middle East region. So those areas are not fully covered yet. Of course, there are a lot of initiatives going on across the world. It might change even tomorrow as the providers, the carrier providers are significantly working on understanding that the IoT is a global impact, global deployment, and so they are working heavily on to supporting this IoT initiatives. Most of the companies are supporting NB-IoT, and LTE-M is available mostly on the North America part of that. But if you see that if you have NB-IoT, you are in mostly on the China and the northern part of Asia, Russia and all. But if you are more into LTE-M, NB-IoT, then you are in the North America side of that, right? So there is a difference between that. So within the LTE-M and NB-IoT, you cannot use one single network frequency across global. Right? That itself is the difference here. So there is no single spectrum that we can use it in the carrier side, the cellular network carrier side across the global. Now let's take a look at the LoRaWAN specific or LoRa specific, network, right? In this case, especially public network, because anybody we can, create a private LoRa network by deploying our own gateways and device and networks and things like that. But if we wanted to look at, the public network availability, there are again, depending upon the different countries, different level of network available. Not everybody is everywhere is covered by LoRa. Still, it is significant spread across the North America, Russia, little bit on the west side of Europe, India, Australia, and China, and things like that. So pretty much everywhere, covering except the Africa and the Middle East regions, not there. So there is a public network, but it is may not be available across all the spaces, even though it is there, depending upon the local service provider and how the initiative happening within the country and things like that. So again, this is not something we can apply. We can just take this single as a single network communication across all our deployment if the use cases are across global, right? Especially moving logistic type of implementation may not be suitable as in all over the countries, all over the world, right? So there are certain limitations in terms of the coverage, as but they are really a good contender on getting into this space. Pretty much LoRaWAN is the one of the main thing that we can consider as part of our selections, network selections. Sigfox on the other side, and they are again the low power spectrum, but it's more like a private network. They are available in the, especially they are right now 100% available on the eastern part of Europe, but they are significantly working on to cover the North and South America as well as Russia. But if you see here, there is still a lot more improvement coverage has to happen in the Asian region, African region. There is no major support available there. But I think Sigfox is working with the local carriers to spread their private network into that each and every country. They are again coming up, but they have not covered up. So now considering all of them, right? So we have seen that the cellular network, LTE-M and NB-IoT, that covers pretty much some areas. LoRa network covers in a different aspect of areas, and then Sigfox is covering. So we could not see that one single wireless network that is available across global as of today. And this is where we need to pick and choose the right one. We may not able to settle if it is a global deployment, right, or a different country deployment. We may not able to pick and choose one particular network. We need to look at the multiple wireless network spectrums to decide which network that we need to go with. We may go with NB-IoT as pretty much covering a lot of the places, and the LoRa combination or Sigfox to LoRa combination. It's all purely depending upon where you want to deploy, how you want to deploy, what network is available within that range, whether should we create our own private network or should we use the public network. It's all based on all those parameter combination. And then we are going to see all of those in the subsequent section of this webinar. Now, by comparing this, the comparison of these networks, right? So let's take a look at the four major things, right? Of course, these are the biggest contender on this large scale implementation, specific to remote location implementation. So now let's go one by one. The specification aspect of that, of course, the specifications are vary from each providers. The LoRa Alliance is an open standard specification. We can create our own private network. We can use the existing public LoRaWAN network provided by providers, or we can adopt the most common available network and things like that. And this Sigfox is again, it's a private, very secure, but very limited coverage in terms of the global network. So it's upcoming one. Probably, definitely, they will be getting into the larger space. But yes, they are really good contender on this case. Compared to LoRa, Sigfox is not yet covered fully, but they are working on that in the North America space, especially. And then the cellular network, of course, every country has every provider. There is no single provider that covers across global, right? So we have to go by partnering with any cellular provider on the local region to get the coverage. So this is a slightly challenging one from the global implementation aspect of that, because we cannot associate with every country's provider and then implement it as it varies from place to place. It has to be more regionalized implementation if we are going with cellular based. LTE-M and NB-IoT is a real good contender on this case, because their coverage is very much across North America and Asia region, except India and Africa. So they are pretty much available across, and the combination of NB-IoT and the cellular could be a very potential thing when we are applying at the global level. Licensing aspect, NB-IoT is a licensed spectrum, specification spectrum that requires, to work with the ISP providers. And LoRa is more like unlicensed. So there is a pretty much approved band between each and every country, and we can, as long as we are in that band, we can apply that as a private network. We can build our own private network with the help of that. On the biggest difference between all these four things are related to the volume of messages that supported by them and the power consumption. So we need to look at that. Three key parameters here: the data rate, and then the messages per day, and power consumption. This is the biggest comparison that we need to do that before we identify the right network for our implementation, if it is across global or if it is limited to a specific area and the coverage of the area, right? If it is a remote location and there is no cellular network coverage, then we have to look at either LoRa. I think we have to look at more of private network, like a LoRa based implementation. If it is the remote location, but there is a coverage on the network side of that by provider, either NB-IoT or cellular, depending upon the power consumption, right? Because NB-IoT consume medium level of power, it's low to medium, and then cellular required high power consumption. So if the power source to the device is not a question, but we need a high data rate in terms of the volume of the data streaming and the unlimited data we need to pass it, then definitely a cellular network is the biggest player there. Of course, there are other things like how many number of devices we are going to deploy, how they are all spread across in the particular region. So we need to look at all those parameters as well. So considering that, still there is a limitation on the Sigfox side if you look at that, but I think this limitation will go off after some time as they are really coming up with a newer, support on this. On the in terms of the power consumption aspect, definitely LoRa and Sigfox is the lowest power consumption spectrum, so which can be applied in the devices that supports them. However, high traffic, if you are looking at sending a lot of data through the network, then definitely we need to look at NB-IoT or cellular network if the network is available on the particular region. So final conclusion, the application usage level conclusion is that, if it is an NB-IoT LTE-M frequent data, if it is required frequent data, then that we need to look at that if the power consumption is not a big question. Cellular network is definitely, yes, it's a streaming data. If you're looking at sending a video data over network, streaming a video data, then definitely cellular network or other Wi-Fi network is the most common cost-effective way of applying that. And in terms of the low frequency but periodic data is going on low power consumption and the Sigfox availability, then we need to look at the Sigfox network as most best option. But LoRa is definitely a good candidate for us to consider on the remote location, especially if you want to create a private network within your factory environment, within your region, or within your implementation space. But we are not ignoring 5G, the upcoming 5G. Of course, 5G is one of the biggest contender for all the four that we have seen so far, right? So we are hearing a lot more, advantage over 5G. But from the IoT implementation aspect, we are looking at three major things, right? We are looking at the bandwidth of data. We are looking at the speed of the data that we can send it, and we are looking at the battery life. So I think these are three things are important factor that we are considering for the IoT device based network selection, right? In this case, 5G has really a good contender on all the four that we have seen that. As the 5G is promising, better battery life, up to 10 years of battery life for the IoT space. If it is, not a streaming data, streaming video, but in terms of the speed of the day network availability, in terms of how fast we can send the data to over the network, how much bandwidth we can consume and send the network, all of them are more than 100 to 1,000 times better on the 5G network. But still, this is purely based on cellular provider, right? The cellular provider has to support it. So if it is a remote location, the 5G network is not available across the US, across North America, across Asia region. And definitely, we need to look at that in the future aspect. This is not something we can think about today's scenario, but definitely we can look at down the line 5G as one of the key selection for IoT deployment. As of now, there are a lot of initiatives happening on the 5G implementation. So pretty much, you can see the coverage available across different regions. These are all hotspots available there in different regions. And, pretty much North America, Europe, and China, Australia, and all covered up pretty much is available. At least in the testing level, it's available. But in the Africa, still Africa and India and some of the region in Russia, the network is still not available, right? So it's upcoming one. It is not available today. So today's use cases we cannot consider it, but we need to think about this from the future aspect of that. So definitely 5G is one of the biggest contender in this space. The question is between the how much data we are producing, how much data the device is producing, number one. How much power required for the device to produce the data, and how long the data is going to be produced. What is the volume of the data, number of data that being produced. The more number of data that the device is producing, it's going to use higher number of bandwidth on the network, and of course the battery life is going to be down, right? If the less number of times the device is generating data and the data packets are very smaller packets that can be sent in a lower bandwidth and low consumption of the data rate of power, and then the power consumption, definitely the power is not a big challenge here, because it's coming, periodic basis, right? The data is coming in a periodic basis. So now, considering all of them, right? If you put together the map on global network on what are the different networks are available and where is that, definitely if you look at that, if you are really thinking that power is the biggest challenge for me in my device deployment, then definitely we need to look at LoRa as one of the biggest player there, and we need to look at the LoRa based implementation. If the power is not a biggest problem, but I wanted to send more data, like a logistic scenario, or maybe more data in terms of the data that is going through network, most higher network is like a machinery network data that going through network, then we need to look at other type of one, such as NB-IoT or cellular network. 5G is definitely a feature. They are in the very sweet spot of low power, high data rate, but today it's not available, right? So we need to think about that in the future. Now, coming to the smart industry, right? Smart manufacturing industries. Today's webinar is more about that, right? It's not about generally on every IoT application. We are considering smart manufacturing as one of the key area where we need to look at the right wireless network. Now, smart manufacturing use cases, we need to look at the use cases first, the most common use cases that we are adapting in the smart manufacturing, especially on the IoT specific aspect of that, because smart manufacturing not just IoT, but it's also robotics and 3G, 3D printing and other things. So there are other cases, but we are looking at more IoT specific scenario here, as the context is more specific to IoT based smart manufacturing, and look at the use cases and think about the use cases, right? So let's take a predictive maintenance. The predictive maintenance is pretty much measuring the machine performance and understand how much machine usage And based on that, based on the lifetime of the machine, based on the usage, we are predicting what will be the right time for the machine to do the maintenance work for the machine, right? Before the machine stop working, correct? So that's a kind of a use case. So if you take this particular use case, definitely we need to know that the machine running time. So there is a continuous data coming out of the machine about the usage, about the performance of the machine, power consumption by the machine, the vibration level of the machine, the output of the machine. So all those different parameters we need to measure more frequently, more frequently, almost like streaming. So that case, there is a high possibility of high volume of data generated by the machine. The high volume of data has to be sent over the wireless network, especially we are considering like a wireless network, right? So sent over the wireless network, definitely read a higher rate of data transfer and unlimited data transfer, right? Then our use case should be more like a high data rate and unlimited transfer. So we need to pick and choose the right one. Additive production is more like how the additive production is more like a design and print. Again, it's a more 3D printing. And in this case, again, the volume may not be a bigger because we send a large instructions to those printing machineries that are in remote places, but we need to send a large data size, right? We cannot send the small pockets. We need to send a large data size of instructions to those machineries to operate on that. In that case, we are looking at the high size of data that's going in high volume of data, right? So high volume of data is something we need to consider. The data rate may not be that, but the packet size may be bigger sizes. Asset performance, right? Moving assets or immobile assets. How the asset is either machinery asset or the logistic aspect of that, right? So we are expecting a high volume of data again, because every moment of the asset, we need to capture it and send it to over the network to data aggregation, analysis part of that. So definitely high volume of data is expected to be produced by the asset, and high volume of data has to go in high data rate, right? So that's again high volume of data. And remote services, right? This is one of the things that today, especially on the global crisis, on the COVID pandemic, remote operation is one of the significant use cases that every manufacturer started looking at. People availability is a bigger question. So now remote management is one of the key implementation on the IoT space. So remote services is one of the thing that everybody is looking at, but this required even more data transfer over the wire. So the streaming of data has to be, it's like a streaming of data, right? Continuously you need to control the machineries through network. So this is one of the biggest one. Definitely we need to consider the streaming of data, and that required high data rate, right? On the quality checks, right? On the quality side of checks, like a quality checks, identifying the quality count, the production count, and the quality check analysis control. Again, this may not be that high volume as the product, depending upon the number of product rate by hour. So we might not require a high data transfer, high volume of data rate, but we need some level of data, which may be considered as a moderate level of data that has data rate by hour, right? This doesn't require high speed wireless network. It can be a simple low power wireless network, right? Low volume, low power network. Inventory optimization, again, this is again, it's not something that it's going to be more significant streaming one, but this is required a more moderate level of data rate to produce it. The last and most important thing is on the smart manufacturing is about robotic implementation and human robot collaboration, right? Again, this is kind of overlapping on the remote services, but collaboration, remote robotic collaboration is more like having a robotics deployed on that and controlling them through wireless network. So that again require the streaming of data, as the every movement has to be captured and every movement has to be controlled. So we need a high streaming of data that goes to the remote robots or devices to make them act as per the need. So that requires high volume of data. So every use case is different, right? If you look at that in the smart manufacturing, every use case is different. Every use case requires different level of data transfer. This is purely on the data transfer, right? We are not talking about power consumption here, right? We are purely talking about how much data that's going to be generated by that particular IoT deployment, how much data, what is the volume of the data, whether it's a streaming data or it's a moderate level of data transfer, or it's equally high volume of data but not a streaming. All these things we need to consider that before we apply that, right? So now, looking at all those options, what will be the right one? That's what we are going to see next. How do we identify that? So the simple approach is, decision tree, right? And we need to put the decision tree in terms of that. It's best practice to try it out. Let's take this as a reference model, right? The number one criteria that I would prefer to consider is the deployment location. Starting with the deployment location, where we are going to deploy the device. Is it going to be in the remote place, or is it going to be accessible place? When you say accessible place, which is near to the factory environment, where the power consumption is not a bigger question. But if it is a remote place where we need a data, right? Let's take, we need a data from the oil pipeline, right? We need the data from the oil pipeline. The pipeline is going to be in the remote places, right? Then we need the data from there on the level of oil available or the water flow available in the remote place where the supply is coming to the manufacturing, right? So we need to measure that level. In that case, that's a remote place. Even though it's a factory case, it is a remote place, right? So the place where we are deploying is the number one criteria that I would consider that. Next, availability of the power. The second biggest one that we need to look at is, okay, it's a remote place or it's accessible place, right? Within factory environment. Within factory environment, power consumption is not a bigger question, but if it is a remote place, definitely power consumption is a bigger question, right? Whether the power is it a battery power that we have to supply along with the device, or is it something, power is available, so we just plug in the power and then give the AC or DC power to that, right? So now that's the next level of criteria that I would consider. Depend upon the power is the bigger difference. Next one is the data level, right? So are we talking about a high volume of data that we need, or are we talking about a low volume of data? Especially if you are looking at the high volume of data and it's a remote place and the power consumption is no, then we need to consider definitely a low power device based network, right? Low power network, wide area network, we need to consider that. If it is accessible, power is not a big issue, still have a low data traffic or high data traffic, either way I can go with yes, cellular network, or I may go with other network, right? So the data traffic is the next question to be asked. And okay, it's a power is not issue or power is issue. What is the right data traffic that I'm looking at from the device? Definitely, we need to consider that before we deploy that any place. Either it's your controlled manufacturing environment, or is it a remote location? We need to consider that data traffic. Now, the other primary things that I also recommend is the number of node. Are we going to deploy a number of sensors or IoT devices within this specific space, or are we going to deploy that in a more wider space, right? Are we going to deploy the number of nodes in a specific region less than the number of command, right? So I consider 10 as a moderate level of that. If you're because this is going to create a lot of cost-effective implementation. So number of node connection within the particular region is very important piece to consider between LoRa versus other network. As if you're looking at one or two devices deploying in a remote place where there is no power available, but there is a network provider, right? They provide NB-IoT or LTE-M support. Then I would consider that to go with NB-IoT and LTE-M support devices, because the number of devices are less and also the cost of gateway is reduced there. If we are going with a remote place where the power consumption is a question, and also we need a higher low traffic, but not a streaming traffic, then we need, there is no network provider available there. And then the availability of the cellular network is definitely a questionable one, like Africa, right? Then I would recommend to go and build a private network with the help of LoRa gateway and node and things like that. So considering that factors, we need to think about that, especially smart manufacturing cases. Most of the cases, it's going to be power should not be the problem, because it's a very well controlled. Most of the cases, probably 90% of them, are in a remote, accessible environment where power is not a problem, but the number of node is going to be definitely high, because we are going to put a lot of sensing points, and each points is going to create a lot of data, right? And each sense points, if you consider as a network, right, you need to create a local network, right? So that means you need to consider either LoRa if the data traffic is not high, but you can also consider the cellular network, either cellular network or NB-IoT based network, depending upon the availability. So the question here is the selection approaches. First, number one, the question is, where are we going to deploy this? Is it accessible or remote place? Number two is power. Is it power is available or not? Number three is the data traffic. Number four is the number of devices that we are going to deploy. So all the five things that we need to consider before we select a particular network. Without considering this, please do not do that, as this is going to be a bigger and bigger. Today it may be a couple of devices. Tomorrow, if we are expecting that particular location, we may have to deploy n number of devices. Then definitely think about the longer term approach in terms of the selection of the network provider. Definitely a question of the cellular network provider availability. If they are not available, then I would recommend Sigfox or LoRa based network. Especially if it is high volume traffic, high data that we have to produce it, we may not be able to use Sigfox because of the limitation number of data that we can send over the private network. That's the way they are controlling it, right? But if it is the case, then you need to build your own LoRa-based private network to build it. I don't recommend public LoRa network for the smart manufacturing cases, because we don't want that network being accessible from by outsider. Especially smart manufacturing, you need to have a better control on your machineries than going to the public network. So apart from the location, power availability, number of node that's connecting, the network availability, we also need to consider other cases if you are looking at the smart manufacturing use case. So low power, high rate, low rate, perfectly fine. But the other five parameters that I would consider, based on that, this chart has been created. This matrix has been created. The number of device within the range, definitely a significant one. The structural interference, right? The structural interference are biggest question. If it is a urban area, very congested, buildings, structures, and things like that, or the mountain areas, then we may have a lot of distractions on the trees and other things. Then we need to think about a different level of network. If it is a public or private network, right? Personal network. Do you want to build you want to use a public network? Yeah, I can use a public network. LoRa network is available. I don't need to worry about that because my data is not a secure data. It can be just generic data like a temperature or something like that. I can definitely use a public network. Then you can leverage that. If it is a secure data, like especially smart manufacturing, smart industries, you wanted to send the more significant data, and like controlling robotic controls, right? Human robot interaction or remote services. I don't think you need to go through the private network, especially you cannot do that actually, in fact, because it's required a streaming network. You need to create your own private network, because this is a more secure channel that you need to create it for your devices to connect with. If it's a high traffic area, but structural interference are there. So there are a lot of structural interference could impact that, and number of devices are very less. Then I would say that between cellular network and NB-IoT or LTE-M, especially if you are in North America and European region, and you are very well towards the cellular network, to be safer side, even though you have a power consumption other things, you better prefer to go with number of devices or less. You better prefer to go with NB-IoT or LTE. But if it is a APAC region and African region where power is not a question, obviously you can go with cellular, or you can build your own LoRa network. The only thing in the LoRa network, when you're trying to create it, you need a gateway as well as nodes. In a cellular network, your nodes can directly connect to the cellular network. So the cost of applying both gate and the number of nodes, if it is a large volume, then definitely consider LoRa. If it is a very small volume, like you want to deploy only one or two devices within 5 kilometer range or 10 kilometer range, then you may look at the cellular-based network if that network is available in that particular region. So based on that, this matrix, this is only recommendation matrix. This can be considered as a reference point, but definitely you need to work on this when you are selecting the right network for your smart industry use case, on how to pick and choose the right network for your cases. We haven't covered the mesh network in this one. Especially, I want to talk about the mesh network. Mesh network is more like your private and your own controlled between the nodes that you can create it. I haven't covered it because I'm not considering that as an industry level grade. Still, it can be applied to a smaller industry. This is upcoming one within the LoRa network itself, within the cellular network, NB-IoT itself. You can create a mesh network and you can control it, but this technology is still, evolving into the next level. So I am not considering that here. This is again, of course, when you go to the 5G and mesh network, that would be the next level of network that could definitely we need to consider in the future. So with that, just a couple of notes on our platform. So we talked about our product, our platform. Fogwing Industrial IoT Platform is our IoT solution, our platform where anyone can come and register. We provide a free number of device connections, so you can come and register, you can get access. You can use the free number of connections as long as you want. There is no trial period. It's a lifetime free service. You can apply that. You can prototype your projects. Very important thing is that we also provide a lot of SaaS-based applications built on top of the IoT solutions. But very important thing in our platform is because we are talking about IoT network selection, right? So our platform is a network agnostic in the sense we support cellular network, we support Sigfox because we don't control that. The network provider is controlling that. We also support NB-IoT, so we don't, because that's again the cellular network for us. And moreover, we are supporting LoRa-based network. So our platform support both LoRa-based network to create a private network as well as the cellular networks or the combination of that. In fact, you can combine the devices, you can build a network of structure with a combination of both the LoRa network as well as the cellular network, and those devices can also communicate between each other through our platform. So our platform plays a MTM role on regardless of the wireless network that you are deploying. So this could be the bigger plus point for our platform because across global, we don't need to worry about where it is, but still the communication between the device to device can happen through our platform. So our industry grade, industry 4.0 high speed data traffic can be happen through our sensors. It supports 3G, 4G network as well as wireless network, Wi-Fi network. We also support NB-IoT based devices, which can also be applied. So we provide, as part of our implementation, we provide all of them. We are a one-stop partner for any IoT industry-grade IoT deployment. As we provide a platform, we provide devices, we take care of end-to-end implementation on that as part of our professional service model. With that, thank you so much for your time. Thank you for listening our view on the selection of network. I hope the matrix and other informations are useful for your selection, for your implementation requirements. If any questions, we can discuss about that.
Great session, Hari. Hari, I have already got a couple of questions.
Mm-hmm.
So the first one is, can you detail on licensed and unlicensed network?
So there is licensed and unlicensed. So every country the government regulate the frequency usage, the radio frequency usage, right? And there is a regulation on that, and each and every regulations applying certain things, right? It's depending upon the country, depending upon the government regulation, telecom regulation, and the government allow the providers, the cellular providers, to use certain frequency of bandwidth, right? And they want to use that band for them to communicate. So certain frequencies, the low frequencies, are mostly used are mostly free, unlicensed. So that's what it means. The licensed in the sense, if the government approve a particular frequency to a particular cellular provider, that frequency is licensed to that particular provider, so that the interference can be avoided. Number one, if there are multiple cellular providers within the country, each one use a different frequency, or maybe in a particular band of frequency. The lower band frequencies are, usually is unlicensed, in the sense it's free to use. So anyone can leverage that, either personal usage or official or business usage. Anyone can use that kind of a spectrums. So LoRa and Sigfox are using such level of frequencies. They are using the lower band of frequency. Therefore, it is regardless of the government, regardless of the countries, they can apply this across the global. So there is no limitation on that, right? And cellular providers are going with the licensed frequency, because they already have a band allocated to them, right? And they are going with that within the band, and they are also providing, by looking at the IoT spaces, right? IoT is significantly, the communication deployment is happening across global. So they are looking at that spectrum, and they are giving a low power consumption. So that's the difference between that. It's purely based on the how the government has defining what frequency is licensed, what frequency are free licensed, means they can be used by anyone depending upon the use cases. That's the difference.
Okay, the next question. Could you highlight security aspects of different networks? Where do you think things like open thread come in?
Okay, so number one, let's categorize this, right? The list of 5 to 6 type of network available, right? Let's categorize this. So first we are categorizing that as a low power or cellular. Like, even if you put NB-IoT and LTE-M as part of the cellular, let's split it as two things. One is a low power licensed frequency, and then low power unlicensed or free frequency, right? Let's categorize that. Now within that, when it's a free frequency, the security is not something, because everyone can use that frequency, right? That means anyone can use within that band range. Then security is something that our responsibility when we are implementing it, right? And we need to consider that as one of the significant factors, because we are trying to create our own frequency, and we are going to leverage the communication with our devices on that particular frequency. And this is where LoRa comes in. Of course, LoRa also brings in certain level of security on that, but still, if you are using a public network within LoRa public network, that means your space is being other people also participate in this space. Then you need to think about whether security is the biggest challenge for you or not. You don't want to have your robotic system going into the public network and being within the LoRa, right? And then being accessed, right? That means it's a significant challenges that other interface could impact your machine at some point, right? Of course, this space also, there are a lot of threat is there in terms of how the communication should happen. So you need to consider like securing the channel that you are using, securing your devices with that, all those stuff. But if it is a license, right, mostly in the licenses space, it's already security is applied because the provider is has to take care of that. So already the provider is taking care of the network security. Provider is monitoring the entire spectrum or the level of band on that. So they are taking care of certain level of security, and the responsibility goes into them, right? So when we are using let's take we are using a cellular network, either 4G, 3G, or we are using NB-IoT, right? If you're using NB-IoT, then that case, then the responsibility of security is already applied by them. But still, you need to secure your devices. Of course, regardless of this question, device has to be secure. And we would recommend that device should not be accessible from outside. Device should be reachable from inside. Means device can connect to internet, but no one should connect to the device from the internet. That's the level of security you need to apply on the device level. So the security aspect of that, definitely, if you are creating your own private network within the space, like a LoRa private network, you want to create it with your own gateway, that's well and good, because you controlling that complete network. But if you don't want, if your use cases are very small and you wanted to have few devices in a random spaces, then you are definitely going onto the cellular network, either NB-IoT or 4G, 3G. Then you need to consider level of security in your device, even though the security is already covered by the provider. still consider the device level security as part of that. I hope I answered that question.
And
If
follow
you
up to
have
that. Yeah, sorry.
if you have any questions further, please shoot a email to us. We are happy to answer all the questions if we are not covering it fully today. Go ahead, sir. Ashik.
Yeah, so follow up with the same question. Do LoRa private networks use the same frequency as public networks? If yes, how is a private network detached from the public? Can public listen into network packets sent in a private LoRa network?
No, definitely the frequency could be same because that's a free frequency, right? That radio frequency, right? Of course, the frequency is going to be same. There is no thing, but the handshaking is going to be the different. The handshaking of between the network and the device is where you control it. Again, the device is in your control, right? So the device is in control, even though the frequency is available, right? Even though it's a public or private frequency, the device has to make a decision whether I should allow handshake or not. So only by authorizing using the token and handshaking, you need to allow that device to hook into that particular frequency. So the question is, yes, if you are in the frequency, there is highly possible that other device or other commands can reach your frequency. If your device is open on the frequency and your device is just openly connecting that and then receiving all the data coming into the particular frequency, definitely it's a threat for that, right? So you need to control it at the device level rather than on the frequency, because frequency is a frequency, either it's a public LoRa network or private LoRa network. It's a free frequency, so there is no control on that, right? That's why we say that build a private LoRa network, but with the highly secure, unique handshaking method within that, between your device and the frequency that you are band that you are creating. So your gateway and node and combination of that could be well controlled within your space.
Okay, thank you, Hari. And one more question. So, which is the most common wireless network used by large manufacturers?
This depends upon the region. I'm sure if it is a North America region, a lot of manufacturers are still working on cellular network, and a lot of manufacturers are working on NB-IoT based network. Definitely, they are working on that space. LoRa is definitely a good candidate in North America region because availability is very high. But again, it's depending upon the private. Are some cases what other smart manufacturers are doing, especially like large companies are doing. They create a private network within the manufacturing network within that, and then from the private network to the public network, they are leveraging the cellular network. So it's a combination of LoRa and cellular network. Within a specific range, they're creating a kind of a mesh network with the help of LoRa, and then from there they connect to the cloud servers with the help of cellular communication. So that creates a combination of solution, and that's the most commonly applied across large manufacturers.
Okay, I think one more question, Hari.
Mhm.
So, do you think 2G network is outdated for IoT implementation?
Um, Not really, because again it's based on the region. If the region only 2G is available, why not we leverage that, right? So we can definitely use that. But 2G is definitely going out. Definitely going out. Even many carriers are stopped supporting that. It depends upon the region, depending upon the carrier, who is providing that. But in the remote places, especially APAC region, Africa region, 2G is still in action. So definitely we can leverage that. But take a decision on based on the longevity of your deployment. If you are considering that you want the devices to be up and running for quite a long time, you are not planning to replace or making it into 3G 5G devices, or your device doesn't support 3G 5G, then it's definitely a question. I would say that start with a better device which supports 2G 3G 4G, and even though the 2G is available today, use it. Tomorrow when they're changing the spectrum or frequency to 3G or 4G, then you change it to that level.
Okay, thanks, Hari. Guys, any more question?
Okay, looks like no other
Yeah.
questions. So please feel free to contact us if you have any question at a later point. You are watching this video in YouTube. Please contact us if you have any questions. We are happy to answer it.
Yeah, thank you. Once again, thank you for joining the webinar. A recorded version of this webinar will be available on the YouTube channel for your reference. And we will be connecting again another webinar next month. Thank you so much. Thank you for your
Thank you
time.
all.
Have a good day.
Take care.